All right, we would like you to watch this video on solving one-step and multi-step equations. Take your notes in your note packet as we go through these examples. You should also be listening as well and not just watching and writing, but listening to it is very important also. Take your notes ahead of time. We will be checking to make sure these are done tomorrow in class, and then we are going to do an equation relay race tomorrow in class as well. So a little fun activity, but you need to have these notes completed so that we can participate in the fun activity. So solving one-step equations. The goal of these is to get the variable by itself. Hopefully you remember these from last year for pre-algebra, but we're going to solve a one-step and a two-step here in this video. So the first one, solve c minus 22 equals 54. So you can see the variable c we want to get by itself, and right now you're subtracting 22. So we need to do the opposite of that. And last year you might have seen a separator line, kind of like a T-chart, down from the equal sign. So we're going to do the opposite of subtracting, and that's adding 22 to both sides. So then this makes 0 on the left, and we get c is equal to 76. Now you should get in the habit of checking your solution every time. All you have to do is substitute the 76 back in for the c and ask yourself, does 76 subtract 22 equal 54? On the second example, we have 63 plus m equals 79. So 63 is a positive number on the left side, and then you're adding the variable m. So to undo and make 63 0, you have to subtract 63 from both sides. And your final answer is m equals 16. So what you do to one side, you also have to do to the other to keep the equation balanced. Okay. The next two examples involve multiplication and division. So this first one, letter A, 2/3 times q equals 1/2. So when you see a number right next to a variable, that means multiplication. So this is a fraction here. You could divide 1/2 by 2/3, but another way to get rid of the fraction is to multiply by the reciprocal. So remember, the term reciprocal means to flip the fraction. So I'm just going to rewrite 2/3 q equals 1/2. And the reciprocal of 2/3 is 3/2. So multiply each side by 3/2. On the left side, you just get a q left. And 1/2 times 3/2 straight across is 3/4. So q equals 3/4. Part B, 39 equals negative 3r. Some students tend to want to add 3 to both sides, but like I said on the other problem, negative 3 is being multiplied by r, so you need to undo it with division. So divide each side by negative 3. Instead of using a division sign, get used to showing division with a fraction bar. So r is equal to 13, or negative 13. All right, and then we have a word problem. Of a group of 13 to 15-year-old girls surveyed, 225, or about 9/20, said they talk on the telephone while they watch TV. About how many girls were surveyed? So there are some key words here. First of all, we're asking for about how many girls were surveyed. So that's going to be our variable. So we'll say let G equal the number of girls surveyed. And I'm going to kind of rephrase what this word problem is saying. They're saying 9/20 of the group is 225 girls. So we should know that of means multiplication. We don't know how many girls were surveyed, so that's going to be G. Is translates into equal sign. So let's set up our equation here. We're going to have 9/20 times G equals 225. And like I said from letter A example, to get rid of the fraction here, we're going to multiply by the reciprocal on both sides, which is 20 over 9. I can put 225 over 1. And then I'm just left with G equals 500. Now, typically on the word problem, you should restate the question in a sentence. So about how many girls were surveyed, you could say about 500 girls were surveyed. And then you should ask yourself, well, does that answer make sense? So 9/20ths of 500 should be 225. So you could also do a small check. 9/20ths of 500, or 500 over 1, is that 225? So 20 divides into 500 25 times. And 25 times 9 should be 225, so it checks out. Okay, so that was one-step equations. Now let's get to multi-step. So to make sure that you are actually listening to this video and not just watching and taking your notes, if you're in Miss Coffey's class, please write a number 4 to the right corner of this heading. And if you're in Miss Buddha's class, please write a number 7 on the top near the heading in the right-hand corner. So those are our favorite numbers. So we're going to be checking for that tomorrow in class to make sure that you're actually listening to this. But don't tell any other students that these are the magic numbers we're going to be looking for. Okay, solving a multi-step. So our goal, again, is to get the variable alone. We need to undo each operation by working backwards. So you have to kind of ask yourself what's going on in the equation. This first one says 11x minus 4 equals 29. So 11 multiplied by x, then you're subtracting 4 equals 29. So I'm going to set up a little t-chart. The second operation that was happening to the variable was subtraction. So we're going to start there by undoing that with addition. So this zeroes out. You're down with 11x equals 33. 29 plus 4 is 33. And then the number beside the variable means to multiply. So we're going to undo that with division. So divide each side by 11. X equals 3. Now the directions do say to check your step, so we need to substitute the 3 back into the original problem. So 11 times 3 minus 4, does that actually equal 29? And then simplify the left-hand side. So 11 times 3, that is 33. Subtract 4 equals 29. And actually check, does 33 minus 4 equal 29? And your last step of the check is verifying that the left side does equal the right side. Letter B, a plus 7 divided by 8 equals 5. So the last thing that was happening was division by 8, so we're going to undo that with multiplication. I'm going to rewrite the problem here. So to undo the division of 8, we're going to multiply both sides by 8. These 8s cancel each other out. You're left with a plus 7 is equal to 40. And instead of adding 7, we're going to take away 7 from both sides. And a is equal to 33. Again, we need to check to make sure this is correct. So I'll do that up here. 33 plus 7 divided by 8. I want to see, does that equal 5? So the numerator, 33 plus 7, that's 40, divided by 8 is 5, and 5 equals 5, so it does check. And the last problem is a word problem. So Hiroshi is buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original price of the skis? Write an equation for the problem and then solve it. So I always highlight the question, what was the original price of the skis? Because that's going to be my variable. We'll say let P equal original price of skis. And then go back and look in the word problem for some key things. So we know they're on sale for 2/3 of the original price. So that's important. He uses a $25 gift certificate, and the total cost is $115. So we know that is in math means equal. So I know that it should be equal to $115. 2/3 of the original. So of means multiplication. 2/3 of the original. And I don't know the original price, so it's going to be 2/3 P. If he uses a gift card, that's going to decrease the amount that you're paying. So we're going to subtract 25. So this is going to be a two-step equation now. So the first step to undo the subtraction of 25, add 25 to both sides. You get 2/3 P equals 140. And to get rid of the fraction, we're going to multiply by the reciprocal, 3/2. Again, you can put 140 over 1 if that helps you. And P equals, so 2 goes into 140 70 times. So now you have 70 times 3, which is 210. So like I said before, restate the question. What was the original price of the skis? Your response, the original price of the skis. The original price of the skis was $210. And again, go back and double check. Is 2/3 of 210 subtract 25, 115. So make sure you double check, especially on word problems. Ask yourself, is my answer reasonable?